In this video, I will teach you how to use integration by part. This is the formula for that. And we will also solve one question, integration ln x the whole square dx. Now, to use this formula, frankly, you need a little bit of practice and make some strategies accordingly. So see how I do this. In this integration, this part, I will call this as u. And then the whole dx, I'm going to call it as dv. So this part is u and this part is dv. Now, basis this, I can always find du because I already have u. U is equal to, this is ln x the whole square. The first term along with the square is my u. Now I have to differentiate with respect to x so that I get du, right? So when I differentiate, it is d by dx of u. I'll differentiate on both sides. So it is d by dx of ln x the whole square as well. So du over dx is equal to, here I will use chain rule. So you have ln x square. So I'll treat this square and write it as 2 times ln x. And by chain rule, I'll write derivative of ln x as 1 over x. Now let me keep du on one side and everything else on the other side. So I have got 2 ln x, 1 over x dx. That is the formula for du. That's the value for du I got. Anyways, once I find that du, next is we know dv is same as dx. That means v has to be x. So I have v as well. See, I already have du, I have v, I know what u is. So now I can use that formula. Therefore, the integration I will become by this formula here is u times v. Well, u is ln x the whole square. This is ln x the whole square. V is x, that's x, minus integration. V is x again, and now du is over here. So du is 2 ln x, 1 over x dx, right? Now, once you write like that, the initial part will remain as it is. I'll just rearrange few terms here. X ln x the whole square looks better that way. Integration, now this x will cancel out. I can take this 2 out, that's a constant. So I've got integration of ln x dx, right? So this part is pretty much figured out. But now we have this integration we want to solve. So let's see how we can do that. Again, for this integral also, you can use integration by part. Second time, let us call ln x as u and dx is du. I'm sorry, dv. So when you have ln as x and dx is equal to dv, it clearly gives us v is equal to x. That's the first value I will need. So I know v value is x, right? Now, as I have u is equal to ln of x, and I differentiate this, I'm going to quickly write this down. This is du over dx. The derivative of ln x is just 1 over x. And therefore, du is equal to 1 over x dx. Now, with all these values, I'm going to use this formula again. The right-hand side of formula is this, and write down the final answer. So you'll get I is equal to this x ln x the whole square stays as it is, minus 2. Now we're using formula for this integral, right? So integration u dv as per the formula is u times v. Well, u is ln x, and v value is just x that we have here, right? Minus, this is integration. Now v value is just x. I'll write that x again. And du is over here. Du is 1 over x dx. So this is 1 over x dx. And this x will cancel out. And you have just integration of dx, which is just x. So I'll get I is equal to x ln x the whole square minus 2. I can multiply 2 inside later on. This is x ln x, and then this is integration of 1 dx. Now integration of 1 dx will become x. So let me write down the final answer here. This is x ln x the whole square minus 2x ln x minus integration of 1 is x. So I'll get 2, and then minus minus will become plus. So this is 2x. And of course, you should write the constant of integration, that is plus c. And this is how your final answer is going to be. So this is how I used the integration by part and solved this integration. And I hope you followed everything. So this is the answer.